1943. The U.S. Navy is losing too many bombers over Europe. They examine every plane that comes back, and they find a clear pattern. The bullet holes are concentrated on the wings, the fuselage, and the tail gunner's position. Almost none on the engines. The brass announces an obvious solution. Reinforce the wings, the fuselage, and the tail. A statistician named Abraham Wald looks at the same data and tells them to do the exact opposite. Reinforce the engines. Wald is right. The brass is wrong. And the reason is one of the most important ideas you'll ever encounter. Imagine the average plane that returned from mission. Mark every bullet hole. The dots cluster on the wings and the tail. There are almost no dots on the engines. If you've never thought about it before, the obvious read is enemy fire hits wings the most, engines the least. Armor the wings. Wald asked one question that changed everything. Where are the planes that didn't come back? They got hit somewhere too. And the data we have, the planes that returned, only tells us where bullets hit but didn't disable the plane. The plane is hit in the wing, it still flies. Hit in the engine, it crashes. It does not return. We never see its bullet holes. The dots on the returning planes show the survivable wounds. The empty zones, the engines, are the fatal wounds. So the conclusion flips. Don't armor where the holes are. Armor where the holes aren't. The Navy is staring directly at the answer, but reading it backwards. This is survivorship bias. When you only measure the survivors, your data is filtered by the very thing you're trying to study. Successful CEOs wake up at 5 a.m., but the millions of 5 a.m. wake-uppers who failed never got profiled. Lottery winners share habits, but those exact habits are shared by every player who lost. Mutual funds with great track records exist because the failed funds got shut down before you saw them. Best-selling books had 1,000 identical quality competitors that got rejected. The math is simple but ruthless. The probability that you see a data point is conditional on it surviving. P of being in the dataset, given the variable. So the distribution you observe is not the distribution that exists. To recover the truth, you have to model the survival filter and invert it. That's exactly what Wald did. He computed the probability of survival as a function of where the plane was hit. Engines, nearly zero survival. Wings, high survival. The dataset of returning planes was a perfect mirror of survivability. Drug trials, stock recommendations, military doctrine, startup advice, architectural longevity. Every Twitter thread that says, "Here's what I learned from interviewing 100 billionaires." If your sample only includes the people who made it, your conclusions are at best half the story, and at worst, perfectly inverted, like the bombers. The most important data is usually the data that isn't there. Wald saw it. The Navy didn't. They reinforced the engines. They lost fewer planes. And 8 decades later, every time someone tells you the secret to success based on the people who succeeded, the ghost of those non-returning bombers should whisper in your ear, "Where are the ones who tried this and failed?" If this surprised you, hit like and subscribe. Counterintuitive math every week.